All right, so we're going to move quickly through some pre-calculus review. So equation of a line, many times you're going to want to put an equation of a line in this form because we'll have a point and a slope. It's not necessary to get it into this form. That's usually a simplified version that the textbooks like, and I don't, doesn't matter to me. All right, so let's work on an equation of a line that goes through this point and is perpendicular to this line. So I need to go find the slope of this line, so I'm going to subtract these two over. So I'll get 5 minus x, divide through by 2. So I know that that's equal to 5/2 minus 1/2 x. So the slope of this line is negative 1/2, and you know that perpendicular slope means negative reciprocal, so that'll give me a slope of 2. So slope of 2 and a point, this is going to happen up a great deal. You're going to have a slope and a point, put equation of a line together. So it's y minus 2, slope of 2, x minus 6, and that's a fine answer right there. All right, so here we're trying to find the equation of a line with x-intercept and y-intercept. So this x-intercept is telling me that it's going through the point 2, 0. This y-intercept tells me it's going through the point 0, negative 7. So if I have 2 points, I can find the slope of the line. So I'll subtract this way, negative 7 subtract 0, 0 subtract 2. So I get a slope of 7/2. I'm going to use this point and this slope, so I'll get y is equal to 7/2 x minus 2. All right, so equations of circles. So you recognize x squared and y squared, x and y. I need to get it in this form if I'm going to find the radius and center of the circle. So I'm going to complete the square. So completing the square on these two, I'll get x minus 4 squared. And I've added a 16 to this side, so I need to add a 16 to this side. So now to complete the square on the y's, I'll get y plus 6 squared, and I added 36, so I need to add a 36 on this side. So this gives me a 52 on this side. So the center is 4, negative 6, whoops, 4, negative 6, and the radius is root 52. All right, so here we're given, we're told what the center is, so I get much of the equation already. Now I need to find the radius. So they're telling me this is the center and this is a point that it passes through. So this center of 5, negative 2, and passing through the point 7, 3 is out here, just to give a visual of where we're at. So this point's right here. So the radius will be the distance between these 2 points, and that's what I need to find. So how do I find the distance between 2 points? Something you just need to know. Here it is in case you forgot. So it's going to be the subtraction of the 2 points. So 7 subtract 5, that'll give me a 2 squared. Then I'll take the 3 and subtract the negative 2, so that'll give me a 5 squared. So this gives me a root 29. So that's the radius. So to put it into the equation of the circle, I'll have a 29 here. So it is necessary to know equation of a circle, distance formula. Another thing that we're going to be doing a great deal of is solving quadratics. Okay, so quadratic like this, first step, always get it equal to 0. So I'll move this over to the other side. And then I like to see if it'll factor first. So let's see if I can get this one. So 3x and x, and I think minus 2 and plus 1 work. So I get x is equal to negative 1/3 or 2. So 2 answers. So it's nice when it factors. If it doesn't, we get to use the quadratic formula. So here on this page, I don't need to use a quadratic formula, and I want to make sure that you know you never divide through by x or cosine or sine, because you're going to lose answers. So subtract it over, get it equal to 0, then factor out an x. Then I have, by the 0 property, x is equaling to 0, or 2x minus 1 equaling 0, so that gives me a 1/2. So 2 answers. All right, So here is our quadratic formula in case you forgot it. So here I'm going to get this equal to 0. This does not factor. So if I put it in my quadratic formula, I get a -1 plus or minus b squared minus 4ac all over 2a. So in here, I have an imaginary number, right? I get root -3. So there are no imaginary numbers in calculus. We don't use I at all. So we say no solution. Okay, this little circle with the line through it, that's actually set notation, so we're not ever going to use that. So if it's no solution, we say no solution. All right, let me stop there.